So what I'm going to do, we're going to get into section 6.5 today, but let me start up by doing a problem from section 6.4. And the reason is we're going to come up with a very short way of doing long division. Provided that our divisor, what's being divided, or not what the dividend, this dividend's what's being divided, the divisor is what's going into the dividend. Assuming that that doesn't have any lead coefficients other than 1. So it's going to be problems like this. So let's say you have something like this. Well, again, what we do is we put it in long division form. And then we do our cycles of division. So again, lead terms. So x squared. And then we multiply x squared into the divisor. So -2 minus a negative, this will be a double negative, so it's a plus. That'll give us x squared, -2 plus 3. And then we bring down the minus 5x, and that's our first cycle. So next, repeat our process here. We'll get x. Oh, just to be consistent, let me make this red, even though it's from the previous step. So we do our subtraction, again, double negative here. And that's going to be -5 plus 3, or -2x. Bring down the +6. And that's our second cycle of division. So again, -2x, lead term, divided by a lead term. And so we get 0. So there's no remainder, there's nothing else to bring down. So this is going to be our answer. Now, the thing with this kind of long division is that it is a bit tedious. So what we're going to do is we're going to do it a little bit faster. So we don't have a lead term. There's no lead coefficient. Well, technically, there's an invisible one. Now, when we do this kind of division where there's just a power of x, the lead term is a x to the positive 1, and there's just the coefficient of 1, we could actually do this a lot faster using a very special technique called synthetic division. So this is going to be 6.5, and what 6.5 is going to do is let us do this much, much faster. So for synthetic division, what we're going to do is this. First, and let's go back to that original problem we just did. Got our x cubed minus 2x squared minus 5x plus 6 divided by x minus 3. So the first thing we're going to do for synthetic division is we're going to extract the coefficients and the constant term if there is one. So if we extract the coefficients and the constant term, we get 1 minus 2 minus 5 and 6. And we're going to set it up like we're doing long division. So that's our first step. Our second step, we're going to take this x minus 3. We're going to ignore the x, actually. This is kind of strange. We're going to put emphasis on 3. And we're going to take the 3 and extract it. But we're going to switch the sign. One more step. Bring down the coefficient for the lead term. So this is how we set it up. We extract the coefficients and the constant. And again, if there's a missing term, we put a 0. And then we take the divisor, we extract the constant term and switch the sign. If this was an x plus 3, we'd be writing negative 3. Finally, bring down the first coefficient. And this is how the process goes. It's a little backwards in some ways. Just like we switch the sign on this, instead of subtracting all the time, which is what we do in the long division, we're going to be adding. So first off, and again, this is going to do all the work. 3 times 1 is 3. We're going to plus sign to remind us that we're going to add. We add these two together. We get 1. 3 times 1 is 3. Add these together. Negative 2. 3 times negative 2, negative 6. Add those. We get 0. So what does this mean? Well, what it is, the farthest number to the right is the remainder. So in this case, remainder is 0. Then the next number is the constant term for our solution. The next term is the coefficient of the x term. And then this is the coefficient for the x squared term. So that means our answer, x squared plus x minus 2. So it's the same answer we got before using long division. Now let's go through this again. This is one that takes some practice. So let's say we're going to do this one. checking, make sure I got these here. All right. So once again, first thing, we got our divisor. I'm sorry, we got our dividend, and we have our divisor. So we're going to extract the coefficients. Now we got to be careful here. X to the fifth, x cubed, x squared, x to the 1 constant. We're missing a term. We don't have an x to the 4th term. So when we do these coefficients, we got the 6. We got to put a 0 for x to the 4th. Then a -2, +4, -3, and a 1. So first thing, extract those coefficients. Second thing, extract the constant, switch the sign. So instead of -2, +2. And then last setup, drop down that first coefficient. So that's our setup. Extracted coefficients, extracted this constant and switched the sign, dropped the first coefficient, and now we're ready to go. So 2 times 6 is 12, and then we're going to be adding these. 0 plus 12 is 12. 2 times 12 is 24. -2 plus 24, 22. 2 times 22 is 44. 4 plus 44, 48. 2 times 48, 96. 96 plus -3 is 93. And finally, 2 times 93, 186. And we get 187. So we multiply, add, multiply. Multiply. Oh, sorry, skip this one. So we multiply, and then we add, multiply, add, multiply, add, multiply, then add, multiply, and then add. So how do we interpret this? Well, farthest number to the right is the remainder. And then the constant, the x term, the x squared coefficient, the x cubed coefficient, and then the x to the 4th coefficient. And so what we're going to get in this case, we have a remainder. So we're going to have the plus the remainder, and then we divide by the divisor. And so we have to go back to the original question. What was the divisor? Well, this is the dividend, and that's the divisor. All right. There we go. And that's going to be our answer. So let's do one more. So let's say we have this one. So let's say you have something like this. Now, dividend, divisor. So again, we're going to set up with an extraction of coefficients. There's a little more room here. Now, again, we're missing some terms. We're missing an x to the 6th, an x to the 4th, an x squared, and an x term. Now, for x to the 7th, we extract a 1, x to the 6th, it's not there, so we've got to put a 0. We don't just leave it blank. We don't ignore it. X to the 5th is a 1. X to the 4th, again, is going to be a 0. X to the 3rd is negative 10. X squared and x to the 1 are both zeros. And our constant is going to be 12. Let's double check. Makes sense. Okay, we're good. Now this one, though, because we have a +2, we got to switch the sign. Make it a -2. Drop down that one. So now we're ready to go. -2 times 1. -2, add it, we get -2. -2 times -2. +4, add them, we get 5. -2 times 5, -10, add them, -10. -2 times -10, +20. Add these, we'll get +10. -2 times 10, -20. Add these, well, -20. -2 times -20, +40. Add those, we get +40. -2 times 40, -80. Add those two, we'll get -68. So now, figure out our answer. Remainder term, constant term, coefficient for x, coefficient for x squared, coefficient for x cubed, coefficient for x to the 4th, coefficient for x to the 5th, coefficient for x to the 6th. And so what we finally get is x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus 10x squared minus 20x plus 40 minus 68 over, and then we got to go back because this is a remainder. We always got to put it over the divisor, x plus 2. So any questions about that? So that's the deal synthetic division. And again, the divisor, unlike long division, we can actually do a lot more with long division. So we got to have something of the form to do synthetic division. It's only for this type of problem. And so to summarize what we're using this for, it's limited in this sense. So let's say we have polynomial p of x. Oh, sorry. Divided by x minus c. The way we set it up is we'll take c, we have the coefficients of p of x. Or if we have polynomial p of x, x plus c, then we're working with negative c in the coefficients of p of x. So the key thing to remember with synthetic division is it's got to be something of this form for our divisor or something like this for our divisor. We don't have any coefficients here or any lead coefficient other than that invisible 1. And we're working with x, not x squared or x cubed or anything like that. So that's how we're doing the synthetic division. So one last thing to mention in this section, it's called the remainder theorem. And basically, this is what it says. I'm going to use f of x. I'll use f of x. So what it's saying, if the polynomial f of x is divided by x minus c, and we get whatever we get as a remainder, maybe a remainder of 0, a remainder of 4, whatever remainder we get, then that remainder equals f of c. So this is just another way of computing f of c. Now, you might say, if we're doing this through long division, this seems kind of counterproductive in some ways. It's going to take a long time to do this using regular long division. Why not just plug in c into f and do the calculation? And you're right, I'd agree with you. But in this case, with synthetic division, you can actually do this pretty quickly, and you don't have to worry about taking powers or something like that. So let me give you an example. Let's say we want to compute, let's get this. Let's say we have f of x equals 6x to the 4th plus 10x cubed plus 5x squared plus x plus 1. So let's say we have something like this, and we want to find f of 5. Well, I mean, we still could get some pretty big computations out of this, but let's say we're going to find f of 5. Well, again, we can divide this by, so this is our c. Our c is going to be 5. X minus 5. So if we do this and just look at the remainder, we'll know what f of c is. Now, this is sort of a pain to do doing long division, but let's do it using synthetic division. Maybe it'll be better, maybe it won't. So away we go. 5 times 6 is 30. Atom, we get 40. 5 times 40 is 200. Atom, we get 205. 5 times 205, 1,025. Well, we're getting some multiplications in here. Atom, we get 1,026. Okay, so let's break out a calculator finally. So 1,026 times 5, we get 5,130. Atom, 5,131. So our remainder is this. So what this says is that f of 5 equals 5,131. So is this a better way to do things? Well, let's compute f of 5 using, well, what we've got here, using our order of operations. So f of 5 is 6 times 5 to the 4th plus 10 times 5 cubed plus 5 times 5 squared plus 5 plus 1. Now 5 to the 4th, let's see here, this will be 6 times 625 plus 10 times 125 plus 5 times 25 plus 5 plus 1. So this will be 3,750 plus 1,250 plus 125 plus 5 plus 1. So this will be 5,000 plus 125 plus 5 plus 1, or just skip a few steps, what we'll get is 5,131. So which method you think is easier kind of depends. Some of them, I don't know. I kind of thought the synthetic division was pretty competitive. Like you've got to, bust out a calculator. I only had to bust out a calculator once using the synthetic division method. You had to do it a few times. So, whichever, hard to say. All right. Let's see. So last type of problem I want to cover from this section. So we have something like this. They want us to solve a polynomial equation. And let's say we have and they want us to solve it using synthetic division, giving us one of the solutions. So what does this mean? Well, what this means is if we replace x with -1 in this equation, here's our x's, and we do our computations, we're going to get 0. That's what a solution in this case is going to mean. It satisfies the equation. If we replace x with -1, we'll get 0 equals 0. So that being the case, what that tells us is that if we divide this using synthetic division, do x minus a -1, what we're going to get is something without a remainder. So let's take a look. So first, extract our coefficients. All right. Now, how do we handle the division on this? What it means is that x equals -1. So what this is saying is x cubed minus 4x squared plus x plus 6 is equal to 0. There's some way of factoring out a term, x plus 1, times some polynomial p of x, where this times p of x gives us that. So what we want to do, we want to find p of x. And so to do that, we're going to take f of x, and say this is f of x. And we're going to do is divide it by x minus 1 to get p of x. So if we divide both sides by x minus, or x minus negative 1 or x plus 1, that's going to give us p of x. So saying that x minus 1 makes this equals 0, that's just going to tell us we can factor this out. It's one of the zeros. And so what we're going to get is if we say, well, this is f of x, they're the same thing. Well, you're going to find p of x by dividing by x plus 1. So that's what we're going to do. Now, here's the thing. Remember, when we have our divisor, we got to switch the sign. So instead of plus 1, negative 1. Bring that down, and away we go. Negative 1 times 1, negative 1, atom, we get negative 5. Negative 1 times negative 5, positive 5, atom, we get 6. Negative 1 times 6 is negative 6, add them, we get 0. And so we have the remainder constant, the x coefficient, and the x squared coefficient, or x squared minus 5x plus 6. So where does this get us? Well, originally, this is what we have. F of x is x cubed minus 4x squared plus x plus 6. And we find out because x minus 1 equals 0, or when we plug it into f of x, x minus 1, x equals x minus 1, we plug that into here, we get 0. So what that's going to tell us, we can factor this into a p of x. And it's going to be x plus 1 because replace this with minus 1. Minus 1 plus this will become 0. Zeroes everything out because that's what they told us. And now we just found p of x. So we want to find all the solutions to this. That means all the numbers, if we replace x with those numbers, this becomes 0. So we were told negative 1 is one of those numbers. What that means is that you can factor out an x plus 1. That's what that's saying. So if you put in a negative 1 here, add up the 1, you'll get 0. So what other numbers make this equal to 0? We got to factor this. It's a guess and check method because you have an invisible 1 as your coefficient. Two numbers that add up to negative 5, multiply to 6. X minus 2, x minus 3, there's x plus 1. So this means this becomes 0. x is 2. This is 0 when x is 3. And of course, this is going to be 0 when x is -1. So our answers become and that's going to be our answer. All right. Well, let's go to section 6.6. So 6.6 is about rational equations. And the idea of 6.6 is this. We want to eliminate denominators. And so what we're going to be looking for is an LCD. So let's say we have something like this. Now we want to find an LCD, so that means we want to list all the types of denominators. So we have a 5, we have an x, and we have a 5x. So this one just factors to a 5. This one just factors to an x. Now this one factors to 5 times x. Now we want to make all these denominator factors look the same, or factorizations. So this one's got a 5 and an x, but this one's missing a 5. And then this one's missing an x. So we'll get 5x, 5x, and 5x. So that tells us what our LCD is going to be. So what we're going to do is multiply all through here by 5x, trying to get the denominators to cancel out. So we're going to distribute the 5x over here. So we'll cancel denominators. So the 5x's, these are just going to cancel. They're gone. Now this one, 5 goes into 5x. I'm going to leave behind an x here. And then x goes into 5x. We're going to leave behind a 5. So now the denominators are gone. Well, what's left over? Well, we have 7x minus 4. So we'll get 7x minus 4 is 9x minus 20. And then we solve for x as usual. So we can add 4 to both sides. So x is equal to 8. So let's take a look at another one. Now let's say we have this one. So once again, let's look at all the denominators. Well, there's really only one, x plus 30, and that just factors x plus 30. So this will become our LCD. So we're going to multiply through by x plus 30. Now, again, the goal is we want to get rid of these denominators. We're going to distribute this to here, that term and that term. So what we'll get and then we look for cancellations. X plus 3 will cancel. X plus 3 and x plus 3 will cancel. And then this one, we have to distribute that too. Let's double check this real quick. Just see something here. Just want to make sure. Sorry. Okay. So combining like terms. Subtract x from both sides. Here we go. Subtract 9 from both sides. What you're going to get is -3. And this looks good. This looks pretty good. But here's the problem. Let's go back to the original problem. The issue here, if x is -3, you're going to get division by 0 and a division by 0. So this actually doesn't work out. So it is possible for these types of questions to have no solution. So even if you've done the algebra completely correct, you could get a result that actually doesn't work because this will cause division by 0. So these are the questions where you're not always going to get a correct answer. Let's do one more. So let's say, let's do a good one. All right. So what I'm going to do, I'm going to first factor these denominators. And well, we can actually just take a look at them like this. So we're going to list all the denominators. Now, again, what we want to do, we want to get rid of them. So let's factor them. This is sort of like taking, we did this with algebra and fractions. We were doing algebra now, but we worked with just fractions, numerics. And we would take each denominator and break it down into a product of prime numbers or prime factorization. Here again, we're going to factor everything. So two numbers that add up to 3, multiply the -10. Again, using the guess and check method, looking at the invisible one, so to speak, in front of our x squared. Then two numbers that add up to 1 and multiply to -6. Add up to -1, multiply to -12. There we go. So we want to come up with an LCD. We want to make these prime factorizations the same. So x plus 5, x minus 2, but it's missing the x minus 4 and the x plus 3. Better put those in. Then the plus 3 and the minus 2 here, we need the 5 and the 4. And then finally, the 4 and the 3, we want to get the 5 and the 2. And so now what we can do is look at what our LCD is going to be. Now let's double check, make sure we've got this right. 5, 5, 5, okay. 2, 2, 2, we're good. 3, 3, 3, 4, 4, and 4, and 4352, 3254. Okay, looks good. And the 2 and the 4 are minus, and then the 3 and the 5 are plus. Okay, we're good. So this will be our LCD. So we're going to take this and multiply through by this LCD. It's a little tight here, but we'll make it fit. And I'm going to go ahead and factor these just like they were factored here. So what we'll get, we'll have 4 over, instead of x squared plus 3x minus 10, x plus 5, x minus 2, minus, and then instead of x squared plus x minus 6, x plus 3, x minus 2, instead of x squared minus x minus 12, x minus 4, x plus 3. So we're going to multiply each of these by that LCD. So what we do is we actually multiply both sides of the equation, and we distribute the LCD to each of these terms. Squeezing in here. And now we look to cancel. So we can cancel the x plus 5s, the x minus 2. We can cancel the x plus 3, the x minus 2. We can cancel the x minus 4, the x plus 3. So what do we have left over? We're going to have 4 times x minus 4, x plus 3. In this one, we have the 1, the x plus 5, and the x minus 4. And then finally, we got the 3, the x plus 5, and x minus 2. So what we're going to do, we're going to FOIL these and then multiply by these constants, and then we're going to get some quadratic and solve the quadratic. So let's see here. If we get a quadratic, we might see some cancellations. So this one will be 4 times this. Now this is going to be, let's squeeze this in here, 4 times x squared plus 3x minus 4x minus 12. subtract 1 times x squared minus 4x plus 5x. Again, I'm just foiling is what I'm doing. Minus 10. Oh, minus 20. We'll check. Squared minus 4x plus 5x minus 20 is equal to 3 times x squared minus 2x plus 5x minus 10. So we get 4, combining like terms now. X squared minus x minus 12. Subtract, and 1 times anything is just anything. X squared plus x minus 20 is going to be equal to 3 times x squared plus 3x minus 10. So now we can distribute 4x squared. So we'll be doing this. So 4x squared minus 4x minus 48. And then we'll distribute this minus sign. To get minus x squared minus x plus 20 equals 3x squared plus 9x minus 30. So make sure we got our distribution. Okay, we got it. Got it. So we can combine like terms here. We'll get 3x squared minus 5x plus 20 is equal to 3x squared plus 9x minus 30. And just double checking. Missing something here, minus 48, so that's going to be a 68. Minus 28. So let me double check. 4x squared minus x squared. Another thing that helps when you combine like terms, cancel these as you use them. So minus 4x and minus x is minus 5x. Okay, we're good. Minus 48, positive 20, negative 28. So we've got that. All right. Now we're going to solve for x. Now, good news is we can subtract 3x squared from both sides. So we're not going to have to deal with a quadratic. So we'll get minus 5x minus 28 is 9x minus 30. Subtract 9x from both sides. And we'll get negative 14x. Add 28 to both sides. Minus 14x is equal to negative 2. Divide by negative 14. positive 2 over 14, which reduces to 1/7. Let me double check the answer here. That is correct. So that's how you want to deal with these rational equations. You want to cancel out your denominators with some sort of LCD. I want to go back to one of the problems in 6.5 real quick, when we talked about solutions to a polynomial. So what solutions mean, I just want to go over this because I think I went over that a little too fast. So we have this problem for number 27. Let's pick a different one. Let's go with number 28. So a way you can think about this, let's call this f of x. So f of x is x cubed minus 2x squared minus x plus 2. And so what this is saying is this. F of negative 1, which is going to be negative 1 cubed, minus 2 negative 1 squared, minus negative 1 plus 2, well, this comes out to 0. And that's what it means exactly. Now, this is kind of strange. Why do we say that when we put a value in for x, when our function is a polynomial, that when making x that value causes the polynomial to be 0, why do we call that a solution? Well, what's going on here is that we're factoring, technically, f of x into a polynomial p of x times x plus 1. One of the things with polynomials is you can break them down into a product of factors. That's something you can do. Now you have to get into complex numbers to make it work fully, but that's what we're actually saying. So we need to find this p of x. That's what we're trying to do. So when they say negative 1 is a solution, they mean that you can factor f of x into a polynomial and then some factor where, if you replace the x with negative 1, this will become 0, making everything else 0. So if the solution was 2, just saying, then we would need to have this as x minus 2. Because if 2 replaced x, this would be 0. It makes everything 0. Again, the solution to a polynomial simply means it's a value of x that turns the entire polynomial into 0. But 2 is not a solution. Negative 1 is. So we have to have this as a factor. So when x is negative 1, negative 1 plus 1 becomes 0. Makes everything 0. So knowing that, this tells us we want to find p of x. They've given us f of x here. So if we divide both sides by x plus 1, that means f of x over x plus 1 is equal to p of x. So let's find p of x. Well, again, we're going to use synthetic division just because it's fast. So again, extract the coefficient and the constant. 1, negative 2, negative 1, 2. And then we're dividing by x plus 1. Kind of switch the sign to negative 1. Bring down 1. So now we go. Negative 1 times 1, negative 1, add them, negative 3. Negative 1, negative 3, is 3, atom is 2. -1 times 2, -2, and we get 0. So this means if we divide f of x by x plus 1, we get p of x. So what's p of x? Well, here's the remainder, which is 0. That kind of helps. The constant term, coefficient for x, coefficient for x squared. Or x squared minus 3x plus 2. This is p of x. So this means we can write f of x like so. And we want to factor this. So we can do that. F of x. Two numbers that add up to -3 multiply to 2. X minus 2. X minus 1. X plus 1. So it actually turns out 2 is a solution. Well, go figure. So what we've done is this. We've taken the polynomial and we've turned it into a product of factors. And that's what we wanted to do. So now we find, well, what numbers of x make this polynomial 0? In other words, what are the solutions? Well, we still have our x is minus 1. And they told us that at the beginning. But here, x will be plus 1. And then, go figure, x will be 2. So our answers will be these. And that's it. So that's 6.5 and 6.6. I'm going to put out a standalone video for 6.7 and some of the early chapters of sections of chapter 7 as soon as I can. But I just wanted to do this overview of these two sections. And if any questions, let me know.